Okay, so this is still in the same unit, it's just that different package of notes. So it's the smaller notes that should say B, I believe, on it, like video notes B. So learn to write 6, solve a system of linear quantities by graphing a solution region. So, okay, so I'm gonna just write for some of these. So these ones I'll show this in black. So when it's inequalities, we know are
Riley Larson to the office, please. Riley Larson to the office.
inequalities are less than, greater than, equal to, less than, equal to. So if we're just dealing with less than and greater than, whenever we have points and I need to draw a line, instead of drawing a solid line, when I'm graphing this, I'm going to draw a dotted line, or it could be a negative slope, and then I'm just going to draw my dotted line through those slopes. If I have a greater than or equal to, I would just draw my solid line like we're used to, greater than or equal to. So it's saying shading. So depending on what the answer is, so like if here's my graph and there's my line, so this one would tell me that it's a greater than or a less than or equal to. It has my equal to because it's a solid line. When it's saying shading, wherever my answer region is, so it could be less than or greater than, that's where I'm going to shade. I'm going to shade everything either below that line, or I would shade everything above that line, and we're going to explain to you where you would shade in the next couple of problems. So in these problems, so here's two problems, you're still going to graph them as if there's an equal sign. So don't pay any attention to that this says y is less than until we actually have to like draw a line and shade. So right now, just plot the points like it was like as if this says y equals negative 4x plus 5. So my y-intercept is 5. So 1, 2, 3, 4, 5. And my slope is, out of 1, I'm going to go down 1, 2, 3, 4, and I'm going to go over 1, 1, 2, 3, 4, over 1. So there would be my points. This one, y equals 2x plus 2. I'm going to pretend that it's just an equals. So this is going to tell me plus 2, start there, and I'm going to go up 2 over 1, or down 2, back 1, down 2, back 1. So there's my slopes. So then, using this rule, I should have a dashed line for this one. My line here should be like this. And since this has an equal to, this one should be a solid line. So I already have them drawn in here. So here we go. This was my dashed line, and here's my solid line because of this one is just less than, this one's greater than or equal to because of that equal to. So the last part now is we just have to shade. And the shading, you can normally follow this sign, but there's always a way to check. So I feel like if I was to shade less than this line, less than here, looks like it would be everything over here. And I can check if I'm right. Less than looks like it's all right here. And I can always check if I'm right by just plugging in a number that's less than. So if I look at the point right here, 0, 0, it's in this shaded region. That's less than this line. So if I plug in 0 for x and 0 for y, this should be a true statement. So 0 is less than negative 4 times 0 plus 5. And then, right? Yep. So then I have 0 is less than 0 plus 5. 0 is less than 5. Is this true? Is 0 less than 5? Yes. So that means everything that I shaded is correct. So if I wanted to, I could shade a little better and have it go up to, I shouldn't include that line, but it's everything behind that line. And so it's everything just behind this line. And I double check by just picking any point. I could have picked, if I wanted to, this point right here. I could have, if I'm in my pen. I could have picked this point, or I could have picked this point, or I could have picked this point. But to me, 0, 0 is the easiest to plug in. So again, we're doing the same thing over here. Shading. Just by looking at this, looking at something that is greater than this line, if I'm looking at values greater than, I'm thinking, this one looks confusing, right? Up here looks like it's greater, but down here, so I'm just going to take a guess and say that it's this. I'm going to take a guess. That's what looks greater to me. It looks greater to me. So then I can always check. I can't choose 0, 0 as my point here, so I want to choose another easy-ish point. So I'm going to choose, maybe I should do black. I'm going to choose this point. And that point right there is I went over 0 and I went up 1, 2, 3, 4, up 4. So I'm going to plug in 4 for y, That's a 4, that's not a y. And I'm going to plug in 0 for x, and I'm going to see if this is true. So y is greater than or equal to 0 plus, 4. 4 is greater than plus 2. So is 4 greater than or equal to 2? Yeah, 4 is greater than or equal to 2. So I know I shaded in the correct spot. So that's how we do that. So I look at where the line is, where y is less than. Here's where all the y's are less than. I look for where my y's are greater than, and it's going greater than up here. Down here I'm getting to more negative numbers. So now let's try where there's two of them together, so a system. So I'm going to graph them each separately. So this one I'm going to graph, and that's going to be, if I wanted to rewrite this, it's 3 over 2x minus 2, so minus 2, and then it's up 1, 2, 3 over 1, 2, up 1, 2, 3 over 1, 2. It's a less than or equal to, so I want a solid line. That's not what I want. Line with arrows, and I'm going to do black. So right here, and I have a solid line. Okay, so then for this one, I want to try shading. So where does it look like y is less than this line? So I'm going to guess right now, and I'm going to do this. I'm going to guess that it's over here. That's my guess. I might be wrong, but this looks like where it says y is less than. So I can always double check by doing a point. So a point that I like is right here. And that point is, what is that, 1, 2, 3, comma 0. So if I plug that in up here, 0 is for y. 0 is less than or equal to negative 2 plus 3 over 2 times 3. Maybe I should pick a number that's going to nicely cancel out. Let's go here. Let's go 4. Let's choose that point and not this point. And so that way this is 4. So then I have 0 is less than or equal to negative 2 plus 3 times 4 is 12. 12 divided by 2 is 6. Is 0 less than, so negative 2 plus 6 is 4. Is 0 less than or equal to 4? Yeah. So I know that I colored in the right stuff. So if I want to, I can just color back over all of this. Yay, I was right. I don't care about that. Woo. So that's where that one's shaded. So then I'm going to graph, and I guess I will do this one in blue. Y is greater than 1 minus x, or negative x plus 1. So I'm going to go plus 1, and then it's going to go, and this is the same thing as negative 1x, or negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. And since this is just greater than, I'm going to do a dotted line very badly since I don't have a straight edge. And when I shade in here, so first before I shade, because I don't want to be wrong, in this color I will shade in blue. So it's greater than. I think that's going to be up in this area, up around here. And I can check by checking that same point. Do you see that this same point is also above? So I'm going to use that same point, 4, 0, and plug it in here. So 0 is greater than 1 minus 4. 0 is greater than negative 3. Well, 0 is greater than negative 3, so I was right. So I'm going to shade now everything above this line. And then my answer is going to be where those colors overlap. So that's going to be everything. Oh, I should have done this in a pen. It's going to be everything where those colors overlap. So from here and over, and then if this graph, if we made it bigger, it would be everything like, and I'll do this in yellow now, if we kept going, it would be all of these. So it's wherever my shades overlap, and you can always check to see if your shaded region is correct by picking a point. So before, this is not what I want you to do. This is what I want you to do. Let me erase these answers. I didn't realize that was written in there. Delete. Okay, so before class, you're going to do this. So solve this one. So graph this, shade it. Graph this, shade it. Wherever those shaded regions overlap, that's going to be your answer. So that's what I want you to do before class tomorrow.